Let's continue with our shape batcher. Today we're going to start drawing lines. And the way lines are going to work in our shape batcher, let's go ahead and draw it here. If we have 2 points and then a line going between them. So we have a line segment. I'm going to call this one A and we'll call this one B. The way line segments are going to work in this library, we're going to be able to specify a starting point and an end point, a thickness, and a color. Lines are actually going to be made out of oriented rectangles. And we can get a picture of what that would look like. So this here would actually be the line segment. But then we would draw a rectangle around it and orient the rectangle according to the line segment. Depending on the thickness, the actual drawn line would look something like this. We'd have a line here, a line here, here, and here. And then what we're looking at here is this is the, from here to here is the thickness of the line. And then we need to figure out what these 4 points are so we can actually render the line as a filled rectangle. The way we do that is first calculate this vector from A to B. And I'm going to call that the first edge. And the way that looks is we just simply say B minus A. And I'm going to call that E1 for edge 1 will be equal to B minus A. And that will give us a vector pointing from A to B. I want this vector in normalized space, meaning I want this vector to be a direction that has a magnitude of 1. So the next thing I'm going to do with that vector is I'm going to normalize. Now that we've normalized E1, I want to add in this half thickness to the equation because that's going to tell us how far we need to go from this point to get to the edge here. Because this is going to be a half thickness and this is going to be a half thickness. And we can figure that half thickness in simply by multiplying E1 times the half thickness. So we'll just multiply those two things. Once we have that, now we're going to be able to find every other direction we want to get. So we want to get the 4 different directions. We have one direction, which is to the right. Now we need to get the next direction, which is back to the left. That'll be E2. E2 is trivial because it is simply the opposite sign of E1, and so we'll just multiply E1 by a -1. The next thing we want to do is find this direction. I'm going to call this N1, and that stands for normal. Every line segment in 2 dimensions is going to have 2 normals, one pointing that direction for N1 and the other one pointing the opposite direction for N2. N1 can be found using E1, and all we have to do is switch the X and the Y from E1 to be opposites. So we're going to put the first parameter as edge1 dot y, and then the second parameter as edge1 dot x, and then multiply the y by -1. That'll give us this direction here for N1. And then once we have that, finding N2 will be definitely really easy. All we have to do there is, again, reverse the sign of N1. And so N2 is that. So now we have all the information to find all 4 of these points along for this rectangle. The first point, let's just call this, I'm going to put Q1 for quad 1. Q1 is going to be equal to our starting point, which is A. So we start at A. We're going to add N1 because we want to go up. And then we want to go left. So we're going to add edge 2. Now over here, we're going to have quadrilateral point 2. And so Q2 is going to start at B. So B is our starting point. We're going to add N1 because we're going up again. And then we're going to go to the right, which is E1. Okay, so let's add in E1. Q3. I think you can kind of get the gist of where I'm going with this. We're going to start at B again. We're going to add now N2 because we want to go down. So we want to go down this way, so let's add in N2. and then we want to go right again. So let's add in E1, since that goes in that direction. And then finally, quadrilateral point 4. That'll be Q4 is going to start at A, so we'll put A here. We're going to add N2 since we're going down. And then we're going left, so we need to add in E2. These equations right here, combined with these equations up here, will give us everything we need to draw this quad, because once we have these points, we can send them to our vertex array, and then that'll get sent to the graphics card, and now we're drawing filled rectangles as lines. So let's open up Visual Studio and let's start coding all of this stuff. We're back in the MonoGame pal tester, which is our flat library tester. We are in the shapes class. I noticed something last time. This ensure started and ensure space, we do not want these to be public. These are just going to be internal methods for the shapes class to see if everything is started and we have enough space. Let's start a new function down here. This is going to be called Drawline. We're going to provide a vector 2 for the A, which is the starting point, a vector 2 for B, which is the end point of the line segment. We're going to then provide a thickness for the line, and then a color. Okay, so now we're ready to draw the line. We're ready to start putting in this code that we talked about back here. So the first thing is, let's find our E and our N values. Okay, so if you look at this, we want to find E1, normalize it, and multiply it by half the thickness. Well, first thing I want to do is make sure the thickness is clamped in our utility class by certain values. I only want to allow a minimum of 1 and a maximum of 10, we'll say for now. In fact, we can put this up here at the top of our class. The min line thickness is going to be 1 and the max line thickness is going to be 10. So let's go ahead and throw that in here and then right here. Now we're ensured to get a thickness that is within the correct bounds. Okay, now that we know that, let's find the half thickness. That'll just be the thickness divided by 2. And then we can go back to this code. Let's find our E value, which is simply B minus A. And then we want to normalize it and then multiply by the half thickness. This is a vector 2, not a floating point. So then we want to normalize E1 and multiply by the half thickness. That'll give us E1 and everything we need for that. Let's get E2. It's just going to be the opposite of E1. So we'll just say negative E1. Let's get N1. And if we go back here, N1 was a negative E1y and an E1x. So we'll just create that. It's a negative E1y and an E1x. And then the N2 was just the opposite sign of N1. Let us now get the points on our quadrilateral. So the first point, Q1, is going to be A plus N1 plus E2. In fact, I can just do this. There we go. There's Q1. We're going to do A plus N1 plus E2. Let's copy this 4 times. This is going to be 2, 3, 4. This is B, B. Now we're at N1, N2, N2. And then over here we have E1, E1, E2. Now that we have all of that, we don't need this anymore. We can send the information to the index and vertex arrays. And to do that, I'm just going to copy this information here and paste it down. Let's increment the shape count. And then let's just make sure we got all of this information correct. In actuality, this should be fine. But here we need to put in the quadrilateral points. So this is going to be Q1, Q2, Q3, and Q4. And I think we've done everything we need to do there to draw a line. Actually, the only other thing we need to do is we need to ensure that we have started the batching. And then we also need to ensure that we have space. There we go. And this function wants a shape vertex count, shape index count. Okay, we'll just put those in here. Okay, that looks like we have everything we need. Let's go ahead and go back to the main game class and let's see if we can, well, first of all, let's just run it without doing anything else and just see if this compiles and see, just make sure we have everything looking correct from last time. Okay, that looks right. We still have that rectangle that we can move there. Let's try drawing a line. Okay, let's just start at 16, 16. And we're going to kind of go diagonal across the screen. Just pick some random values. I think, let's see how big our screen is. Our screen is 640 by 480. Let's just do 1280 by 720, and then we'll be able to still watch the stretching in action. There we go. That goes a little bit above it, so let's change this number. So instead of 768, this is going to be 720. Perfect. Okay, so there it is, drawing a line with a thickness of, what did we say that was, 2? Thickness of 2. Let's now put in the max thickness, which I think we said was 10, and just see what it looks like. And that looks correct. So we're getting a line with the thickness of 10. Now one thing, I don't think I want to allow a thickness of 1. I think I want 2 to be the minimum thickness. So let's put a 1 in there and just see what it looks like. Yeah, I don't think I like the way it looks at 1. Let's see what 2 looks like again. Yeah, I think I want that to be the minimum thickness we allow for each line. And so the way we're going to handle that is back in the shapes, draw a line, we provide a thickness, we actually clamp it, but then I'm going to increase the thickness by 1. So then the thickness will always be at least 2. So if I do put a 1 in here, we're just going to pretend that 2 is 1. Okay, so if we put 1 in there, it's actually going to be a thickness of 2, but as far as the library is concerned, that's a thickness of 1. That's the thinnest it'll go. So let's actually test the color. So let's just put in a red here and see what we get. It looks like it's giving us the right color. We can draw a few lines. Let's do red, green, and blue. And let's change these. We're going to make some random values. This one will also start at 1280 minus 16. And then this one will start at 720 minus 16. Let's see what that looks like. Okay, that looks good. So we have our blue line, our green line, our red line, and everything seems to be drawing perfectly. I'm still getting the arrow command working just fine. Escape works there. That's the intro to line drawing. We can actually probably optimize this code a little bit to be faster. But that's it for basic line drawing.